Here we have a few differentiation examples. The first one I'm going to show you is find dy by dx for y equals 4 pi x cubed. Now, the key things when differentiating this is to realize that we're going to use the rule for y, basic rule on all of these, y equals k to the kx to the n, goes to, when you differentiate it, dy by dx equals k n x to the n minus 1. And you just got to appreciate what is your constant, k, and which bit is your variable, x, with the power. So here we've got 4 as a constant, we've also got pi which is a constant, so 4 pi is effectively your k, and we've got x cubed. So therefore put it into the rule, and basically what we do, if you want to know a short, easy way to remember the rule, think of times by the power, take 1 off the power. So dy by dx will equal the constant times by the power, so 4 pi times by the power of 3, so that gives you 12 pi. And we're going to take 1 off the power, it's power of 3, so the power becomes 2. And that is the answer. Next one, notice I've chosen different ways to describe them. That was find dy by dx. Now we're going to differentiate with respect to x this expression. We don't have an equation here, we're just an expression where we're going to find the differential with respect to x. We're still going to use the same rules. So we're going to now the way we write this is we write d dx of 6x squared minus 9x to the 4 all over 3x. Now the first thing we need to do is simplify that. And the way we simplify that is we've got to divide. We've got to divide everything on the top by everything on the bottom. So 6x squared divided by 3x, well 3 goes into 6 2 times. And x into x squared, remember x is effectively x to the 1, subtract the indices, 2 minus 1 gives you just x. And we're going to minus from that, 9 divided by 3 is 3, and x to the 4 divided by x to the 1, well again we just subtract the indices to get x to the 3. So, and we're going to find the differential of that. We're going to differentiate that with respect to x, so we write d dx of that. Now the next line is where we do the actual differentiating. So we differentiate 2x, so effectively we've got 2x to the 1. So remember the rule, times by the power, take 1 off the power. So effectively 2 times 1 is 2. Take 1 off the power leaves you 0. We'll come back to that in a second. Minus 3 times 3, times by the power is 3. 3 times 3 is 9. And then take 1 off the power. Power is 3, take 1 off the power is 2. Now x to 0, anything to the power of 0 is 1. So effectively this whole thing here is just equal to 1, so therefore we have 2 times 1 gives you 2. So our final answer is 2 minus 9x squared. Now let's look at this last question. Find the slope of the tangent to y equals x cubed minus 4x minus 8 over x squared at x equals minus 1. So we're going to find the slope of the tangent. Well, if we have our curve, so let's say we've got a curve, and at this point we want to find the slope of the tangent. Well, the tangent is a line, a straight line. I'm not very good at drawing straight lines. It just touches at that point, and we want to find the slope of this line. Well, the slope of this line is the gradient, and the gradient of this line, the tangent, is the same as the gradient at that point on the curve. So effectively we're finding the gradient at that point on the curve. Now, most of you should have been taught to find the differential by taking tangents and finding the gradients and working out functions and eventually moving on to differentiation by first principles. So this shouldn't be an unfamiliar concept. So therefore we were going to differentiate this effectively. So if we've got y equals x cubed minus 4x minus 8 all divided by x squared. Now we need to rewrite that as single powers of x. So let's just split the fraction up. Effectively we've got x cubed over x squared minus 4x. I'm going to show you another way to cancel down these fractions. This is another way to do it. over 8x squared, and that will equal x cubed divided by x squared. Subtract the powers, we get x to the 1 minus 4x divided by x squared, well that's x to the 1. Subtract the powers, 1 minus 2 is minus 1, so we get 4x to the minus 1. Minus, and we've got 8 over x squared. Well, that's effectively, we imagine this as being x to the naught, because x to the naught is 1. So you take away 2 from naught, you get minus 2. So we've got 8x to minus 2. Or you should just remember the definition, x 1 over x squared is the same as x to the minus 2. So let's differentiate this. So dy by dx equals times by the power, take 1 off the power. So times by the power gives you 1 lot of x to the naught. X to the naught, remember we said up here, where did we say it? Back in this question, x to the naught was 1. So we got 1 lot of x to the naught gives us 1. You should start to spot when you haven't got a power of x, you just got x, the differential is just whatever the number is in front of it. If you remember back to your early maths days, y equals mx plus c, if you've got a number here and a number here, the gradient of this equation is just m. So if you want the differential of this, dy by dx of that bit, you can just remember that that is just going to differentiate to give you m. M is the gradient, differential finds the gradient. So if you've got just x, that will go to 1, because we've got 1 lot of x. Now times by the power, minus 1 times minus 4 is plus 4. Take 1 off the power, we get minus 2. Times by the power, minus 2 times 8 is plus 16. And we're going to take 1 off the power to get ourselves x to the minus 3. Now, we were asked to find this, the gradient at x equals minus 1. So at x equals minus 1, we have dy by dx equal to 1 plus minus 1 to the power of minus 2. Well, that's the same as, remember, 4 over x squared is an easy way to remember that. So minus 1 squared is 1, 4 divided by 1 is 4. Remember, this is 16 over x cubed, minus 1 cubed is minus 1, so we're going to get minus 16. Add all those up, 1 plus 4 is 5, take away 16 gives us minus 11. So the gradient at this point is minus